You can run a pipe made of stone under your house that will carry water and waste for 200 years without corroding, without softening, without leaching a single chemical into anything that passes through it. No joints failing, no walls going egg-shaped, no microplastics, no dioxin, nothing. There are clay sewer lines under Washington, D.C. that were put in the ground in 1815, more than 200 years ago. They are still functioning, still carrying what they were built to carry, still doing their job. And here is the honest part, stated up front, because that title makes a large claim and I am going to deal with it now rather than at the end. Stone pipe, and by that I mean vitrified clay pipe, is better than PVC in nearly every measurable material property. It is harder, more chemically resistant, more abrasion resistant, longer lasting, and it does not degrade. That is not opinion. That is published, tested, verified data from the National Clay Pipe Institute, the American Society for Testing and Materials, and every municipal sewer department in this country that has ever had to choose between the two. What it is not is cheap to install, and that single fact is the entire reason you have plastic under your house instead of ceramic. Clay pipe costs about $8 a foot, PVC costs about $5. That is a $3 per foot difference, and that $3 is the whole story. It is the reason a 6,000-year-old building material that outperforms everything around it was quietly replaced in one generation by a petroleum product that the man who runs the largest sewer system in the Northern Hemisphere will not use in his city. I am going to walk you through exactly what this material is, how it is made, what it does that plastic cannot, the honest numbers on cost and installation, the part about PVC that should concern you, and the one thing about clay that decides whether it belongs under your house at all. And then I am going to give you the part that ought to make you uncomfortable, which is that the replacement didn't happen because the old material failed. It happened because the new one was faster. I spent 40 years as a maintenance man at a 60-room motel on a Florida highway. 60 rooms means 60 toilets, 60 sinks, 60 showers, and a sewer line under the parking lot that carried all of it to the main. That motel was built in the early 60s. The original sewer was vitrified clay, heavy reddish-brown, smooth bore, 3-foot sections joined with mortar. In 1991, a section of the parking lot settled and they dug it up. The clay pipe underneath had been in the ground for roughly 30 years. I went out and looked at it before they hauled it off. The bore was clean. The walls were smooth. The joints had cracked slightly where the ground moved, and that was the failure. Not the pipe, the ground. They replaced that section with PVC, Schedule 40, lighter, longer sticks, faster to run, half the labor. The plumber had it in by lunch. 14 years later, I was standing over the same trench. The PVC had developed what the industry calls ovality. The round pipe was not round anymore. The walls had begun to deform under the soil load. Not collapsed, not broken, but flexing in a way that clay never does because clay does not flex. It is ceramic, it is stone. That was the moment I started paying attention. And the more I looked into it, the less comfortable I got with what we'd done to the pipe under this country. Here is what vitrified clay pipe is, in plain talk. You start with a blend of clay and shale, not topsoil, not garden mud. These are specific mineral clays that have been mined and blended for their firing characteristics. The raw material is extruded under hydraulic pressure in a vacuum chamber, which eliminates air pockets and laminations. Then it goes into a computer-controlled kiln and gets fired to over 2,000 degrees Fahrenheit. At approximately 2,000 degrees, the mineral particles in the clay fuse. The technical word is vitrification, and it is the same thing that happens when sand turns into glass. The particles melt together at the molecular level and form an inert ceramic. When it comes out of that kiln, it is no longer clay, it is manufactured stone. And here are the numbers, because this is where it gets embarrassing for everything else in the ground. Mohs hardness, 9 out of 10. For reference, a fingernail is 2.5, glass is 5.5, a steel file is 6.5, and diamond is 10. Vitrified clay pipe is a 9. You can hit it with a jetting nozzle at 5,000 psi and 80 gallons per minute, and it does not care. The National Clay Pipe Institute published that number, and it has been verified by every maintenance department that has ever cleaned one. Compressive strength, 18,000 pounds. That is the average. The ASTM standard for a 12-inch pipe requires a 3-edge bearing strength of 2,600 pounds per linear foot. The original standard from 1912, the first ASTM pipe standard of any kind, required only 1,200 chemical resistance. Vitrified clay is resistant to virtually every chemical that will ever pass through a sewer pipe. Acids, alkalis, solvents, industrial discharge, hydrogen sulfide, which is the gas that eats concrete and corrodes metal in sewer systems. The Clay Pipe Development Association in the UK confirms that clay pipes are resistant to all common chemicals, with the sole exception of hydrofluoric acid, which you are not putting down your drain. Abrasion resistance. Because it is a ceramic with a Mohs hardness of 9, vitrified clay can withstand the most aggressive mechanical cleaning methods available. Hydrojetting, chain cutters, mechanical rotting, bucketing. The cleaning equipment wears out before the pipe does. That is not a sales line. That is what maintenance people report. And here is the one that matters most. Lifespan. The National Clay Pipe Institute confirms that clay pipe was first introduced into U.S. sewers in Washington, D.C. in 1815. As of their last published records, some of that pipe is still in service. Over 200 years. When municipalities across the country send cameras down their sewer lines to inspect them, they consistently find clay pipe that is over 100 years old, still functioning as designed, still structurally sound, and still has decades of service life remaining. That is a direct statement from Jeff Boschert, a civil engineer with the National Clay Pipe Institute, published in Trenchless Technology magazine. He also wrote something that should make every utility director in the country sit up. He said that other pipe materials installed in the last 30 to 50 years are failing. That newer pipe is being prioritized for replacement while the older clay pipe continues. In service for the foreseeable future, read that again. The old pipe is outlasting the new pipe. The material we replaced is being kept. The material we replaced it with is being dug up. Kent Carlson runs wastewater operations for the city of Los Angeles, which operates the largest municipal sewer system in the Northern Hemisphere. His, quote, published in a Craftsmanship magazine investigation, was direct. He said, "In our city, we have got clay pipes that are over 100 years old, and they are still operating." He then said, "We are building for generations from now. That is not a time to experiment and cross our fingers for 100 years from now." Los Angeles never switched to plastic, and LA has been through two massive earthquakes. The Long Beach earthquake of 1933, 6.4 on the Richter scale, and the Northridge earthquake of 1994, 6.7. 40,000 buildings damaged, up to $20 billion in destruction. The clay sewer lines under that city survived both. Now the part about PVC that you should know: PVC is polyvinyl chloride. It is a petroleum-derived plastic. It is light, it comes in long sticks, it is easy to cut, easy to join, and easy to install. A crew can run PVC in half the time it takes to lay clay, with fewer joints and less skill. Those are real advantages, and I will not pretend they are not. But PVC is plastic, and plastic degrades. Kent Carlson described the failure mode politely. He said they elongate. Brian Schroeder, the wastewater collections manager for Kansas City, Missouri, used the industry term. He said they develop ovality issues. That is a nice way of saying the pipe is going out of round under soil load. A round pipe that is no longer round is a pipe that is failing. And then there is what is inside the pipe. A 2025 study published in the journal Environmental Science and Technology by the American Chemical Society confirmed that plastic pipes continuously release dissolved organic matter into drinking water, including bisphenols, which are endocrine disruptors. A 2023 study published in the Journal of Hazardous Materials investigated microplastic leaching from PVC. Pipes under stagnant conditions, meaning water sitting still in the pipe, which is what happens in your house every night while you sleep, they found measurable microplastic particles in the water. The Safe Piping Matters Research Coalition published a review identifying plastic pipes as a significant source of microplastics and nanoplastics in potable water systems. Both PVC and PE pipes were flagged. Mike Italiano, the founder of the U.S. Green Building Council, has raised public concerns about degrading PVC pipes, potentially leaching carcinogens into municipal water supplies. He cites reports from the National Wildlife Federation and the Environmental Working Group about endocrine disruptors entering drinking water from PVC, and the manufacturing process itself produces dioxin. The World Health Organization classifies dioxin as a known human carcinogen. The EPA confirms that dioxins are highly toxic and can cause cancer, reproductive and developmental problems, and immune system damage. PVC production is one of the largest industrial sources of dioxin emissions. PVC is classified in a study published in the National Institutes of Health Journal as a substance with strong mutagenic and carcinogenic properties, and more toxic than other plastics due to the presence of chlorine. Clay pipe, by contrast, leaches nothing. It is fired ceramic. It is chemically inert. You could run drinking water through a 2,000-year-old Roman clay pipe, and the water would come out clean, because fired clay does not interact with what passes through it. Brian Vancell of Mission Clay Products in Phoenix said it best. He said, when they dig up old civilizations, all they find is bones and clay shards. Everything else is gone. Now the honest limits, because there are real ones, and I owe you all of them. The first is cost. Clay costs about $8 a foot for material. PVC costs about $5. But the installed cost gap is wider because clay is heavier, comes in shorter sections, has more joints, and requires more careful bedding. Mission Clay's own published data shows that installed cost per foot for clay and PVC with proper bedding is close, around $59 per foot, because the bedding requirements for PVC to prevent ovality add cost that offsets the cheaper material. But most contractors do not bed PVC to specification, and that is part of why it deforms. The second is weight and handling. Clay pipe is heavy. A 4-foot section of 12-inch VCP weighs over 130 pounds. PVC, in the same size, weighs a fraction of that. For a crew working in a trench, that is a genuine daily physical difference. The third is brittleness. Clay is a rigid pipe. It does not flex. If a laborer drops it, it cracks. If someone drills a connection hole carelessly, it cracks. Brian Schroeder in Kansas City said it plainly. He said, "I have got 100 years of people used to being on the backside of a hammer. When a guy is trying to knock out a 4-inch hole, he will create cracks he does not even see. Those cracks might not leak immediately, but they will over time." That is a real installation risk that requires skill and care. The fourth is joint failure. The old clay pipe that fails, and some of it does fail, almost always fails at the joints rather than in the pipe body. The mortar joints used before 1972 allowed infiltration and exfiltration by design. Modern VCP uses factory-applied compression joints that are leak-free and flexible, but older installations do not have those. And root intrusion through old mortar joints is the most common reason a homeowner ends up replacing a clay lateral. The fifth is availability. There are fewer clay pipe manufacturers in the U.S. than there were 50 years ago. PVC dominates the market. The global plastic pipe market is worth $65 to $85 billion a year, depending on whose figures you use. That kind of market share means supply chains, contractor familiarity, building codes, and engineering specifications are all built around plastic. Choosing clay in many markets means ordering in advance, finding a contractor who knows how to lay it, and possibly educating your building inspector. And the sixth is the code situation. Vitrified clay pipe is fully code compliant for sanitary sewer in every jurisdiction I am aware of. It is in the International Plumbing Code. It is in ASTM standards going back to 1912. It is not exotic or unapproved. But many plumbing contractors have never installed it and will either refuse or charge a premium. Now, the scale of what we are dealing with, because this is the part that should make you angry. The United States has over 800,000 miles of public sewers and roughly 500 to 600,000 miles of private lateral sewers connecting homes to the main. The American Society of Civil Engineers gave wastewater infrastructure a D+ on its 2025 report card. The EPA estimates that $630 billion in wastewater infrastructure investment is needed over the next 20 years to maintain and upgrade the system. $630 billion. Most of that is replacing pipe that was installed in the last 30 to 70 years and is failing. Meanwhile, the clay pipe that it replaced a generation ago is, in many cases, still sitting in the ground next to it, still functional, and now being left in service because it is the newer pipe that needs attention. Think about what that $3 per foot savings actually cost. Now I want to tell you about basalt, because it takes this further. Under the Old Town Square in Prague, beneath cobblestones tourists walk on every day, the sewer system was originally built in 1907 by British civil engineer William Lindley. After devastating floods in 2002, the city had to rebuild. They chose to line the rebuilt sewers with cast basalt, that is volcanic rock, melted at 1280 degrees Celsius and cast into tiles and pipe linings. Cast basalt is non-porous, highly abrasion-resistant, and chemically resistant to virtually everything in a sewer system. Its estimated service life is 100 to 200 years. The data published by Greenbank Group and their Czech partner UC, who supplied the Prague project, confirms that basalt-lined pipe lasts 7 to 10 times longer than cast iron and 3 to 4 times longer than nickel-hard steel. Prague now sits on top of one of the most durable sewer systems in the world, built from rock, while American cities are spending hundreds of billions to replace plastic. Brian Schroeder in Kansas City said, "The most honest thing I have heard from anyone in this industry." He was talking about vitrified clay pipe, he said. "From a chemical standpoint, you cannot beat clay. I love it." Then his field supervisor, Matt Thomas, added, "My experience with clay is fixing it," meaning he has never installed new clay. He only ever touches it when the old stuff, the 100-year-old stuff, finally needs a joint repair. His field man only encounters it when repairing pipe that has already lasted a century. And neither of them installs it anymore because PVC is $3 cheaper per foot and comes in 20-foot sticks instead of 3-foot sections. That is the whole story. Speed replaced durability. Light replaced strong. Cheap replaced lasting. And the customer, which is you and me, and every homeowner and taxpayer in this country, pays the difference on the back end. Brian Vencel at Mission Clay always told potential customers the same thing. He said, "I always tell engineers that it's great that you can save some money now, but have you set aside money for replacing these 50 years from now?" Nobody sets aside the money. And then $630 billion later, here we are. So here's what I want you to do this week. First, find out what your sewer lateral is made of. If your home was built before the 1970s, there is a good chance it is clay. If it was built after, it is probably PVC. Your building permit records or a simple sewer camera inspection will tell you. A camera inspection runs $150 to $300, and it is worth every cent because it shows you the condition of every joint, every section, and every connection. Second, if you have clay and it is working, leave it alone. Do not let anyone tell you it needs to be replaced just because it is old. Age is not a failure mode for vitrified clay. Condition is, if the joints are tight and the bore is clear, that pipe may well outlast the house above it. Third, if you are replacing a lateral or building new, ask your plumber about vitrified clay pipe. Ask for a quote on both VCP and PVC, installed with proper bedding for each. Compare the installed cost, not just the material cost, and then think about what you are buying. One pipe lasts 50 years if everything goes right. The other lasts 200. Fourth, look up your city's sewer infrastructure plan. Find out what grade ASCE gave your state's wastewater system. Find out how old the mains are and what they are made of. That is public information, and it is your money that will pay to replace them. And fifth, if you have old clay pipe with root intrusion at the joints, look into cured-in-place pipelining before you dig it up. A liner inside a sound clay pipe body can seal the joints and give you another 50 years without destroying your yard. The pipe body is almost certainly still good. It is the joints that fail, not the ceramic. Tell me in the comments what is under your house and how old it is. I read every one of these, and if you know someone who is about to spend $10,000 or $15,000 replacing a sewer lateral, send them this video before they let the plumber default to PVC. That one conversation might save them from doing it again in 30 years. The Romans built a stone sewer under Rome in 600 BC and called it the Cloaca Maxima. It is still draining the Forum 2,600 years later. We replaced it with a petroleum product that develops ovality issues in 40 years, leaches microplastics into drinking water, and produces a known carcinogen during manufacturing. And we did it to save $3 a foot. There is nothing wrong with PVC that it does not tell you itself, eventually, when it stops being round. There is nothing wrong with clay that anyone has found in 6,000 years. The choice should have been obvious. The fact that it was not tells you everything you need to know about who was making it.